Molecular shapes in a nutshell. So what happens when atoms bond, in particular molecular compounds, where you have nonmetals and they're sharing electrons. So it turns out that these atoms and these molecules have very specific arrangements based on the desire to minimize what's called electron-electron repulsion, which is a way of saying that electrons repel each other, so you want to be as far away from each other as possible in order to accommodate that. So these different shapes you're going to see is based on that premise that electrons want to be as far away from each other as possible, and they take these specific shapes in order to accommodate that. So that's the gist of it. So here's a couple of shapes. We have linear, which is just like it looks like a straight line. And you have to visualize these are three-dimensional images. So some of them are a little bit tougher to recognize really quickly. Bent looks like it's actually bent, like you got a little V shape going. Trigonal planar looks like you have three areas around the middle and they're separated by 120 degrees each. Trigonal pyramidal looks like a squished down pyramid. And T-shape looks like a T. These are just some of the shapes. These are not all the ones you have to actually remember. So we'll go over the specific ones in a second. So this is determined by the number of bonding and non-bonding electrons. So you're going to count your lone pairs and your bonded atoms to determine the shape. For example, if you have two total, in this situation, two total bonded pairs or bonded, what we call domains. A region of electrons we're going to refer to as domains. So there are two domains of electrons around the middle. And these shapes are based on what happens around the middle atom. You don't worry about the outside atoms. That's not relevant. So around the middle, there's two domains. And two domains around the middle always means linear. Same respects, if you have three domains around the middle, you have what's called trigonal planar. And that's how these shapes are determined based on that. Now, lone pairs also count as a domain. So like for this one, we actually, for NF3, we actually have three bonded. As you can see, there's three Fs, but there's also a lone pair on top of the N. So we have three bonded and one lone domain. That's four domains total. So the shape's going to be called trigonal pyramidal because it's three bonded and one lone. So we'll get into the specifics of that in a second. Shapes due to electrons repelling each other and wanting to be as far away from each other as possible. In a region of electrons, single, double, and triple bonds or lone pairs are referred to as electron domain. So even if I have something like this, that's still 1, 2 domains. If I have, this, that's one domain, that's two domains, and then this lone pair becomes a third domain. Now you do want to distinguish lone versus bonded because that specifies specific shapes. Like if you say three bonded total, then you're trigonal planar, which is here. But if you have two bonded and one lone, then you're actually a bent structure, which is what this SO2 molecule is showing you. So you do need to distinguish between bonded and lone areas, but be aware, no matter if it's a single bond, a triple bond, double bond, they're all considered a domain. So here's an example of that. You have A, B3, you have one domain, you have two domains, you have three domains, plus one lone. So three bonded, one lone means you're going to have a trigonal pyramidal shape. If this was a bonded domain at the bottom, and it's four domains total, then you'd be considered tetrahedral. All right, so the theory that deals with this is called valence shell electron repulsion theory, which is just the theory that deals with what happens in order to minimize electron repulsion. So these shapes are as a product of that. So here are the shapes you need to memorize. Linear, two domains around the middle, all bonded. Trigonal planar, 1, 2, 3 domains, no lone pairs again, all bonded. Tetrahedral, 1, 2, 3, 4, all bonded again. Trigonal bipyramidal, 1, 2, 3, 4, 5 domains around the middle, no lone pairs again. And octahedral, 1, 2, 3, 4, 5, 6, all around the middle. The only angles you need to worry about to go along with this is these three. So you need to know linear is 180, the angle between the atoms. Trigonal planar is 120, and tetrahedral is 109.5, which is weird because you expect 360 to be divided by 4 to give the, because all the other ones, if you notice, this is 180, and this is 360 divided by 2, this is 360 divided by 3, and this 360 should be divided by 4, but that's not 109.5 0.5 is. And the reason is you have to think three-dimensionally. And the max you could have is 6 domains. The shapes to be familiar with, you need to know trigonal pyramid or trigonal pyramidal, which is the other way you'll see it referred to at times. Either one. They're 3 bonded, 1 lone pair. You need to know that's trigonal pyramidal. Bent is going to be 2 bonded and 2 lone pairs. So anytime you see 2 bonded, 2 lone pairs, water is your best example of that. You're bent. You're also bent if you have 2 bonded and 1 lone pair, like you do in SO2. So these are the only other total shapes. So we have a total of what, 5, 8 shapes to memorize. Shouldn't be too bad. Here's some examples of this. So CH3L, draw the Lewis structure. You have 1, 2, 3, 4 all bonded. So it's going to be tetrahedral. You could also say this is polar if you want to go a little further with it and point out the fact that there are dipole and limb dispersion forces in it. NO2, you have 18 electrons total. So N in the middle, O, 2, 4, 6, 10, 12. Erase and move because you need to give everything 8 and 1's 8. Now your shape, you have 1, 2 bonded domains and 1 lone domain. So this is going to be a bent structure. CS2, that's a total of 12 plus 4, 16 electrons. So I'm just going to skip to the ending part because you've already had practice with how to do these. So these are 1, 2 bonded domains. So this is going to be linear. I have 5. You have a total of 5, 6 times 7, 42 electrons. So I in the middle. F, 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 F. And of course, your last F is here. Put your remaining electrons down like this. And you have 2 left over because I just did 40. So I'm going to put 2 more right here. So how many total domains do you have? You have 1, 2, 3, 4, 5 bonded, 1 lone domain. Now, there is a shape that goes with that, but we're not going to be responsible for it. So all you have to do for this one is count 1, 2, 3, 4, 5, 6 total domains because there's no subcategory that we're going to memorize for this one. And it's going to be octahedral. And then your last one, pH3, you have a total of 8 electrons. So P, H, 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 lone pair. You have 3 bonded, 1 lone pair. That is a subcategory. That's one of the ones you have to memorize, right? So that's going to be trigonal pyramidal. That's how you do those. And that's how you do shapes.